Hello, everyone. Welcome to episode 262 of the Day Zero podcast. I'm Spectre. With me is Z. Today, we have a fair amount of topics that talk a lot about methodology and such, which is something that Z kind of mentioned last week that he wanted to talk about. And we've got a bit of a wealth of topics that are around that, including some talks because Hexacon and WOOT and a few other conferences have put out some videos of their conference recordings. So we're going to talk a little bit about that. First, though, we'll talk about some blog posts that came across our radar. So, our first blog post to get into here is from CyberArk and is about discovering hidden vulnerabilities in Portainer with CodeQL. So, with CodeQL being in the title, we had to make sure we covered it. And
Always
there's
gets
two
added.
vulnerabilities here. Yeah. So, Z, maybe I guess I'll let you get into this one because I know you love talking about CodeQL.
Yeah, and I'll be honest, there isn't a lot to really talk about here. Since I was looking for things that were more focused on methodology, I will say, unfortunately, a lot of this one is a bit more tool heavy, or at least tool assisted. Thing with CodeQL, as I always mention, is it is researcher in the loop, so it is kind of interesting to see it here. The queries, the vulnerabilities here aren't that interesting. We've got a case of like SSRFs, which are just like they use a query parameter, it goes into like it's a source to sing type of query, and they kind of show the queries that they were running. But I did, think it was at least worth calling out the fact that are a couple of the things that they do mention here. One that I actually thought was interesting is they mentioned how they got some false positives in their figure four. Well, I guess this is just kind of figure four is just things that it was finding. And that is something that's maybe worth noting with CodeQL. They're generally, like, I think Trail of Bits did a comparison. Like, generally speaking, vulnerabilities that CodeQL found were actually or instances of whatever it was declaring it was. Like, it wasn't an entirely false positive. But when you're running the queries, especially these pre-made queries, they are just looking for a case of like whatever this CWE is, which means like a lot of the cases, it may be an actual case, like of hard coded credentials or something, but it's not necessarily with the security impact until you kind of do a little bit more of a knowledgeable query on like what matters, or like you won't necessarily be able to do much with these things. But yeah, I wish they would have gone a little bit more into what their false positives were and like why. Because the nice thing with CodeQL is you build the database with your code, therefore it has a lot of internal knowledge. It's not just looking at like the code looks bad, but like it's actually able to follow a lot of that, a lot of the the data flow, taint tracking. The other thing is taint tracking can kind of mess that up too, because yes, it's tainted, but if you don't have sanitizer set up correctly, sanitized value is still a tainted value. Like you might not be able to get everything through, so that's kind of another aspect that can lead to the false positives.
So I
Nonetheless,
mean,
figure
I think the big thing there is like you kind of mentioned it towards the tail end, but these are like the pre-made queries, right? So like a lot of CodeQL's value, I think, is when you start writing your own queries and kind of
yes.
write with the context in mind. The pre-made ones, it doesn't surprise me that much that they had a bunch of false positives.
No, and it's actually worth knowing. Like GitHub does have that CodeQL query bounty where you write a query that they'll then run against like everything on GitHub, and if it actually finds new vulnerabilities, you get a bounty for it, and they add it in here. So
I
like
kind
they
of forgot
are
about that. That's a
legitimate.
good call out. Yeah.
Yeah, and to be fair, I haven't looked to see, maybe they've dropped that now or something. I don't know for sure that's still running, but they definitely had that program, which I thought was also a cool way of encouraging people to write these and contribute these queries out. And yeah, actually, I was just going to get into that as I pulled up their request forgery query here. You can see on the left side here, like just a ton of CWEs have some queries kind of written for them, and those are just the security ones. A lot of these are also testing other things, inconsistent loop orientation, which I actually couldn't tell you what exactly that meant without. They usually have examples here, like a good
I'm
example.
I'm guessing
um
it means like going positive or negative in the loop, like counting loops, for
that would
example. I'm
be my
guessing it's like that.
guess, but I couldn't
Yeah.
tell you that right off the bat. Yeah, it's exactly that. So they do all come
Okay.
with explanations of them too, like in the help there it says Yeah, it's either increment until an upper bound or decrement until lower bound. So like this one's querying for just like you do that inconsistently, which is a code smell but not a vulnerability. And in fairness, this is also in like a section labeled inconsistent code, not in security. Like it's not meant to be a security thing. Uh, but there are a lot of queries that you can learn from by looking at these things. And yeah, some of the code smells, missing air checks and Go. That's kind of a thing because Go errors are a bit tedious to say the least. But yeah, they have a lot of these queries built in. I treat them, not like say if you're, as I've said a few times, if you're trying to incorporate this as like your generic code scanner, I think you'd be a lot better off using SemGrep in like a CI situation. CodeQL feels like the thing you want to write manual things for. And on that note, like even in this Go code, they have kind of these framework helpers. I saw where they were before recording this, and now I'm not
Of
seeing the
course,
section.
how it always
But it,
goes.
it was basically like a framework helper. So when you do like taint analysis, you want to know what are the sources that are like user controlled. And different frameworks are going to grab these values in different ways. So you would need to specify like this framework, this function's bad. And so for some commonplace, they have that already defined for you. And that's the thing with CodeQL is you need to define those. So if it's not already defined, you need to go in and actually do that for whatever your actual target is. So there's a lot of room to improve upon CodeQL queries that already exist. Like just because a query is written that can catch something, you might need to add a little bit more information to actually make use of it. So again, researcher in the loop, researcher knows what they want. And yeah, I have shilled CodeQL hard so many times. So I'm a big fan of it because it puts the researcher in control and kind of lets you query for what you want. It doesn't need to be a full vulnerability. And so I'm kind of just hitting on that here. The issues they in particular found aren't actually that interesting. SSRF, just source to sync sort of deal, and another one where like using an empty IV, for example, in crypto. They have some other things here. With crypto where they actually wrote their own queries.
I
Really
was just gonna
simple query.
say on that note of like not needing to be used only for vulnerabilities. I mean, another place we've talked about it before is even looking for like exploit primitives. It can be great for that too. And then on the defense side, like you said, it can be used for kind of that the code quality sort of keeping code base consistent sort of problems too. But yeah, on the AES, I thought I would talk about that a little bit, kind of supporting your original point with researcher in the loop, because
Sure, but
the
before you do, I just want to really quickly correct a statement I just made where I said it was an empty IV. It was an empty salt being used. So minor
and an
correction
empty
there.
IV,
Oh,
both.
there was. I
Yeah,
scrolled
it's
through
both.
here and see empty salt. I'm like, oops, made a mistake.
Yeah, no, it was both of them, which was kind of the problem
Gotcha.
there too. So yeah, like the SSRF issue, they just kind of found them with the stock CodeQL queries. It's cool. It speaks to the value that those stock queries can have. But the AES one was a little bit interesting because as I read it, they actually found this issue with manual review. They'd looked at the code and noticed like, okay, they're passing an empty salt and an empty IV. And it's kind of funny because the code has comments here that say like, oh yeah, that's fine. Don't necessarily need a salt, so keep it empty. And if the key is unique for each ciphertext, then it's okay to use a 0 IV, which is just straight up wrong. Like it seems like they wrote this code without actually fully understanding what those values are used for. Because like the problem with using a null IV is it effectively makes it so that your subsequent blocks don't have any uniqueness to them beyond the key. So if you have the same plain text, it's going to encrypt into the same ciphertext, and you can have patterns there and stuff. The key being unique for each ciphertext, unless it's like on a per block basis, that doesn't make the IV irrelevant. So the comments here just seem to be kind of wrong, and it's easy to get fooled as a researcher looking at code to like see the comments and be like, okay, they've already looked here, they've considered this, I'll move on. It's you don't always necessarily consider that the comments are just wrong like they are here. So yeah, there was a null IV and and salt being used here. The impact of that is somewhat limited, but it is a crypto issue. And then they go into the how they would write queries for this problem, which could potentially be leveraged for finding like variants or even across other code bases that might have similar problems, because crypto's hard to use and almost nobody knows how to use it correctly. So yeah, I mean, sort of showing the other way of like, hey, you can manually find bugs too and try to find variants by writing queries for them. That's another like smart workflow to get into, and they kind of they talk about that here with the AES issue.
Yeah, and I think the usage for variant analysis was one of the really big things that got pushed when Microsoft first acquired SEML and released CodeQL publicly, was the idea of using it for variant analysis. I assume they were also using it for variant analysis internally before that. As I understand, before Microsoft acquired them, they used SEML, SEML being the company that produced CodeQL, or possibly the name of CodeQL before it became CodeQL, before it was like a publicly accessible thing. I'm not sure exactly on the history there, but they use this internally, as I understand it, and like I would assume with variant analysis in mind, because that is a good use for it. Is you found a bug in the code base, find other case of that same pattern without necessarily needing to be the same code itself. Um,
Yeah, it gives you some flexibility with how you query. Like you can write your queries in a way that are a little bit more generic than trying to find like the exact same bug or something, which you could just do with Control F or whatever. Yeah, it gives you that flexibility, which is nice.
Yeah, it is kind of hard to write. Like, I've got the one query up here. This is just kind of a predicate for data flow analysis. So it's just writing the is source. So it's just like, okay, it's going to run this on all the nodes and be like, does it match these conditions here? And if you're reading this, like, this is pretty weird. It is hard to get your head around it, but it does start to make sense, especially once you understand kind of its own internal abstract syntax tree, which you can browse. And that's how I learned a lot of like the types that are being used and what that looks like. So I knew how to write some of these things. There are some patterns like you'll just learn, but uh
That is a fair thing to call out with CodeQL, though, is a lot of the time it's not very intuitive at first blush when you
no.
look at it.
I mean, even
It
at
takes
second
time to
blush,
get used to it. Yeah.
it can be a real pain to get at once you do and you know some of the common things. But I remember when I was first getting started with it, like a lot of times it would just be like somebody randomly mentioned some functions like, oh, that is perfect, but I had no way of really discovering that. Or I spent a lot of time in like the not even the documentation, literally just the reference, clicking through a bunch of things to see if one kind of maybe had something that I wanted, because like there wasn't a good way to discover things. That has improved as CodeQL has been more adopted and like there's more information available. But it is kind of it is a problem with CodeQL. Like the whole query language is rough. But yeah, variant analysis, using it just to assist in your own little queries for like, this function. Actually, I think VS Code, when you have the CodeQL thing installed, it'll actually like you do cross refs just by running a CodeQL query. It automatically can do that, which is kind of nice too.
It is
Um,
cool. It is unfortunately pretty slow, which is another
yeah,
thing with CodeQL that's a bit of a drawback. It can take a while to run these queries, especially if they're, you know,
cross refs
computationally
aren't too
expensive.
bad, but
They're not
running the
too
full
bad, but
queries, yeah, like running some full queries can take time. I've had queries take hours where I just leave them overnight to get my results, type of deal. Cross refs are generally pretty quick, and like the things that are more time consuming are a lot more in depth analysis, and it's hard to kind of troubleshoot or debug them at times. Uh, in part because there's not a ton of information on like, oh, do you need a in the like right in this case, like you've got call node and it's like call expression, like what's the difference there? And it can get a bit annoying there, but it is you can write quick queries too that don't take super long, and you can also increase its cache. So when you just make minor changes, so it's like I'm querying this variable and then I'm querying that variable or this restriction, that it keeps a good enough cache to actually be pretty usable, especially when we're talking about using it more for like finding primitives. And for those who are doing bug bounty thing, like there's not a lot of necessarily I mean, there's a lot of open source code and bug bounty too, but like this CodeQL does support JavaScript. So like you can feed it code from the JavaScript on like a page you're visiting and have it find things there and run through that library or those libraries too. So like there is just on like the web, there is that aspect, even if you don't have all the backend source, where you can still make use of CodeQL. I don't think there's a really good way of just like having it build its database and stuff just from visiting a website once. But we've definitely seen some reports of people using it on JavaScript defined. I think I recall one with prototype pollution.
Yeah, now that you mention it, it does sound familiar. And again, that is kind of a cool thing with CodeQL. Like sometimes when you're doing these static analysis kind of things, they are typically tailored to like either C or C++ or like that sort of area where it can work on C and like the web too. Again, it speaks to like the versatility, which is very nice.
Yeah, in fairness, SemGrep, which is quicker, easier to write, supports more languages too. But yeah,
Yeah.
I've just pulled up the language support here in C, C Sharp, Go, JavaScript, Python, Ruby, and some other
Kind of
ones in there.
interesting. It seems like a lot of the times we've seen CodeQL lately, Go has kind of been heavy on the targeting. I'm not totally sure why, but I don't know if it's just because Go's adoption is going up with like services and whatnot, but I don't know. It's just an observation. Maybe it's wrong, maybe it's just anecdotal and
Yeah, I
the
did
numbers don't
notice
back that
that,
up, but
but
yeah. I mean even like
fair
in this
enough.
blog post they're talking about Go too. So, yeah,
Yeah,
it's kind of fun.
Go is a little bit special, I think. Last time I looked, like the repository here with Go. Oh no, they have moved it in. Maybe it's not. It used to be off on its own. It used to be a little bit special, so maybe just now that it's a bit more integrated, or maybe I'm misremembering things. I have not used CodeQL on Go source myself, so maybe I'm
Yeah.
misremembering something. Either way, when it does come to the vulnerability research, like CodeQL feels like that sort of thing that's just really useful to assist you when you already know what you're doing. Like I don't think
Yeah.
the default queries are that useful for you. Like they would be in like an AppSec situation. Not trying to make throw any shade there, but it's really useful, I think, with you in the loop. So I
That's where a
always
lot
want
of
to
its
mention
value
it.
is.
Yeah, that I kind of feel that way. Like its value
Yeah.
isn't as a just run all the queries. Its value is you're in the loop, and for me, this is the first static analyzer that I felt like it gave the researcher control, whereas a lot of things just they have a bunch of rules written for you. It's like it matches or it doesn't, or you need to tune it to do this. Like it's just super annoying. This put it first and foremost and was a game changer for me, so I'm always kind of shilling it. But we did talk about the difficulty in the actually learning the query language because it is weird. It's quite weird.
Yeah.
Um, and just annoying. So that's where I think and I'm actually running the transition this time, but I think our next post kind of plays around with that a little bit. And I want to shout this out to people. It's like, here's something to take a look at. Unfortunately, this isn't available yet, but I am very interested in this. And this is from Theory, Phone Research. We've covered posts from them before, but they've got this static analysis platform they're calling QueryX. And with that, there is a paper with this and a presentation. I'm just pulling both up here. I think I'll have to add that to the show notes. The paper, or sorry, the presentation from last year's IEEE SMP, um, basically symbolic query on decompiled code for finding bugs, and I think that's really cool. Just this is almost, I mean, it's not a code QL; it's a very different query language, but it works on binaries. Um, they do have examples here with uh sorry, I have the wrong I'm talking about that. I pulled up the wrong post. Here's what the query language looks like. And this I think is a lot more readable than what we were just talking about with CodeQL. It's like literally function is source, function parameter node from a function called like receive from, and first thing. A sync is like, does it go into p open? And like this is a very, I think, readable query language based on JavaScript. And then it's just like they do the tank, get alarms, you can iterate through all of them and do something more with it. And it, instead of being I guess declarative like CodeQL would be, this is very kind of more iterative, just like running
Yeah,
kind of
they
linearly.
say basically they wanted to make it like JavaScript because most programmers can understand and
Yeah.
interpret it, which is a smart decision because yeah, like when you have these custom languages that are declarative, like it's annoying to read and write. Whereas something like this, I would be a lot more enthusiastic to jump into writing queries for.
It would be a lot more accessible to write the queries for. Like that's
Yeah.
a big thing is and the way this works is they create their own kind of IR, their decompiler neutral representation that they can kind of run this through because they are working with decompiled or will work with decompiled code or basically with binaries. Obviously, to have like names for the functions, you're going to need symbols or you're going to need to have that information or just use like the automated names from like IDA or whatever. You're not always just going to be able to write like, oh yeah, give me all the malloc calls and just going to magically know it or something. But nonetheless, like, unfortunately, this is not available, but this is really exciting to me to see work on that being done. My guess is this is going to be a paid product from Theory.
Yeah, so I guess we didn't really highlight it, but like something that's important with CodeQL is while it's really cool, you need the source to be able to use it. So like it's free for using on open source. You can pay for it for using privately and like on your own code bases or whatever. But when you only have a binary and you don't have the source, that makes a lot of the automated tooling a lot harder, of course, because you're lacking a lot of context and information. And typically, when you're looking at things like firmware or even certain drivers on some operating systems, you just don't have the source code. The vendors just don't distribute it. And of course, there's still vulnerabilities in those areas, despite the fact that there's no source code. So you want to be able to do some analysis on it. Typically, you have to do more. Like you're forced more into the manual review route because the tools that are out there that exist for uh, black box binary just aren't quite as good because they're lacking a lot of that context. But having a query language like this, again, there is sort of the drawbacks that you mentioned. Like you might have to do some reversing first and actually like name things to make it useful. But it does kind of allow you to do some of that more automated analysis and stuff where otherwise it's a lot more difficult. And to my knowledge, there isn't really a query language like this for like purely black box approach.
Not
So
like this. You could point to something like BAP or Anger, which require more
yeah,
that you understand like their intermediate representations, and you're not really working on the source code level like this is trying to be. This is trying to have that source code understanding. It does the symbolic execution like Anger. I think the paper actually kind of compares. Let me pull open the paper here again.
Anger's a fair shout that I wasn't really thinking about immediately because I don't do it like I don't do a lot of black box analysis like this. Yeah, I mean that's a fair shout. But yeah, like you say, it's not trying to do it quite to this like level where it's trying to bring it up almost to like a CodeQL sort of approach.
It's a lot more accessible to a researcher who maybe isn't going to go learn Anger's, Vex IR in order to really be able to write things there. Like it is a lot more accessible. Being JavaScript, I mean, or being JavaScript like I should say, makes that very easy for anybody to kind of understand and use. But I've just pulled up kind of the website for this, their pattern-based vulnerability analysis tool for binaries. It's not available yet. It says coming soon. I'm genuinely excited. I hope they price this in a way that's accessible for like hobbyists. Being real, like the power of something like this that runs on sorry, the power of something like this that runs on binaries. Like this could be used for, some very high value vulnerabilities, and so they could easily ask, I think, quite a bit. But the challenge there is, I kind of talked about SEML and CodeQL. Like Microsoft used that internally, but most people I doubt had any real knowledge of it. Um, and so like there's kind of the trade-off of, if you get in with the hobbyists, you get the users who will pay versus just having like some big corporate who discovers it and realizes if it's their need. So there is kind of that side. I feel like they're probably going to go more corporate on pricing, but that's just my feeling. I would love it though if they made this accessible for people, because I think it is a really cool tool, or it seems like a really cool tool. Obviously, I have not used it, but it's one of the first things I've seen in a while that does kind of excite me in terms of just research tools.
Yeah. Now in the blog post, again, they kind of take that approach of looking at like a previous vulnerability and saying like, can we write a query for this and find variants? Spoiler alert, they did. They were looking at TP link routers as like an example target, where input from the REST fee from system call, so like presumably attacker controlled input over a packet or something, could reach this get CMD results function, which would pass straight through a popen call unsanitized, so it's just straightforward command injection. So they wrote a sync to source taint analysis on the REST fee from call that goes to popen, and yeah, that's kind of explaining a little bit of their example there. Again, not a crazy like vulnerability, but it's more about the methodology. And yeah, I mean, like you, this would be awesome to have for looking at like certain firmware and whatnot. But yeah, I don't have a ton of hope of it being publicly accessible, just because of theories. Like if you look at their client lists and like the services they already offer with like database, like intelligence database, that's more of their clients. And when you're talking about that sort of area, it's more closed off. To get access to that database, like you have to send in a manual request and everything. Like it's not just a straightforward buy. So yeah, I mean, we can hope, but even if they don't put it out publicly, it does give some inspiration and some ideas maybe for other people to play around with too, which could be neat. So yeah,
Yeah.
I like this post. It's one of those inspirational posts that gets you thinking about some other approaches for doing some things.
Yeah, and if you want more details, like I said, there is a presentation where they talk a little bit more like how they're using symbolic execution for recovering like some stack information to create their decompiler neutral representation and stuff. Like they talk about how some of that works. Like you could try and follow in their steps a little bit. It was before I think they had a lot of the analysis in there. Uh I think there's a reference to that during the presentation, but like there is information that if you wanted to try and build your own sort of thing, like you could build off of what they've done too. But yeah, I mean they likely know the value of this and will make it fairly pricey. But at the same time, like depending on where, because the one tool I'm kind of also thinking of is SciTools Understand, where that's like what, like $100 a month or so.
It's a
I
thousand
feel
bucks a
like
year. I don't think
yeah.
you can
So
purchase it on less than a year
no,
granularity.
I don't think you can either. But I just meant like in terms of what it averages out to.
Oh yeah.
Is like it probably comes out to like $100 a month. I could see this being worth a bit more, but like yeah, I don't know. I guess we'll have to see what their pricing is, but I don't know.
There's a lot of potential with
Yeah,
for new research with kind of how this like using this tooling. So
yeah, there is. So it's
yeah.
interesting. Yeah, calling it out, but unfortunately, not really accessible. Eh, yeah,
And sort of continuing on the topic of some stuff that is kind of emerging and could be useful. So Project Zero put out a blog post from Naptime to Big Sleep using large language models to catch vulnerabilities in real world code. So this is sort of a follow up to a previous blog post that was posted in June, where they've been looking into LLMs and how those can be used in security. Like that's a huge topic at the moment. Something that's like not really understood too well. But what makes this post kind of notable is they were able to find a vulnerability in SQLite, which is obviously pretty widely deployed. Like it is very common in like a lot of systems. And of course,
SQLite.
because of that, it's very like well tested and fuzz as well. So finding a vulnerability by using LLMs sort of is a proof as to the potential of leveraging LLMs. Sorry, go ahead, Z.
Yeah, no, the fact that this was in SQLite caught my attention because like SQLite is, this is one of the only major open source projects I can think of where they claim there is 100% branch test coverage in like their normal configuration. Like this is a well tested code base. They have been using like AFL and they've got libfuzzer on it also. It's been part of OSS fuzz, of course, but like even just before that, like there have been early, very early projects integrating SQLite, making it more fuzzable and integrating that with fuzzing, like going back right to the explosion of fuzzing with AFL in like the mid 2010s. So it's a very heavily looked at project. And of course, there are still bugs in it. Lots of bugs have been found. I'm not going to make any claim like that, but it's definitely like it's an interesting choice for actually finding something. Although what they did find was like a newly introduced bug.
Yeah, it's not a soft target, is how I would say it, because a lot of like novel research we try to look at, especially when we were looking at white papers, for their targets for testing out things and trying to find the provability of like a method, they would target like GCC or like like GNU utilities, for example, which like are pretty soft targets if we're being honest about it. But SQLite is sort of like that hardened target that has gone through a lot of the fuzz testing, so it's a good target to choose for trying to actually demonstrate impact of what LLMs can do.
Yeah, and kind of going into how this works a little bit. Their first blog post, the one this summer, just talks about the project itself, this project Naptime, and how that works. And basically, there were a couple things actually that I thought were interesting. One is they're using basically your off the shelf LLMs for this. I have the backend here, like the examples they show us are using Gemini, which is of course Google's LLM, but you can get access to that, like it is available to use. But they also run this with GPT-4, and they had the example with GPT-3, but it didn't perform as well. But like, so you could kind of see just from what this does, it's basically you've got the back end, which is one of those LLMs. They've added an agent there that gives it the tools like access to a debugger, access to run some Python, access to be able to access or request access to code and see some of that type of information. So it's providing that, and then it's adding some reasoning. And where we talked about, I think it was just last episode, I mentioned like tree of thought. They don't go into these specifics, I don't think. Yeah, of exactly how they're doing their prompt framework. But they do kind of show examples of how it reasoned on this SQLite bug, where you can kind of see like it does have at least a chain of thought going on, probably because they do mention it trying some things and failing. Probably got that tree of thought where it's able to backtrack a little bit and do that sort of thing and kind of figure things out there. You'll have to dig more onto the LMs if you want to understand those specifically, but they provided enough information that like you could probably do something similar, maybe not their same scale or cost because they end up running. So guess I should kind of get to the point with this is one of the insights I think they kind of applied with running Project Naptime and putting it against the SQLite project was just the idea of you've got kind of the very complex issue of vulnerability research. Like you just give it a project and it's like there's a lot you can do. There's a lot of ambiguity in vulnerability research.
There's infinite pathways you could take for even just getting started on a path for what you want to look at.
Yeah. And in the other post, I'm not going to pull it up right now. I do have a quote noted there from it, though, which is, as we've said many times, a large part of security research is finding the right places to look and understanding in large and complex systems what kind of control an attacker might have over the system state. And then they're comparing it with CTFs as isolate challenges do not reflect these areas of complexity. That was more talking about the benchmark that they were going for this vulnerability research, comparing it with, but that idea is kind of important. There's so many options, and a big part of it is just where do you even start looking and finding that attack surface, choosing to dig in somewhere. And so what they did here is they basically just went with variant analysis. Rather than trying to have it just find bugs, they use the LM to try and catch variants, which they also noticed some of that fuzzing wasn't doing very well. Fuzzing could find a lot of bugs, but fuzzing was not very successful at finding variants of those bugs. It would find one case, then it's not going to be able to use that knowledge to find another unless it's like right beside it. It won't find variants of it. And so attackers have been able to do this manual variant analysis, and they kind of took the idea that perhaps variant analysis is a better fit for LLMs rather than just the open-ended vuln research problem. So kind of their approach here was to take commits, removing the trivial documentation commits in SQLite, and prompting the LLM and the agent, giving it the commit or the commit message and the diff for all the changes, and asking it to review the repository for related issues that may not have been fixed. And they kind of draw a lot of relations between how a human researcher might approach this, where they're not entirely sure, but it's like this sort of idea with incorrect, like kind of incorrect assumption, incorrect handling of these constraints here, and this bug that was being fixed could lead to incorrect results. So there might be some sort of bug along that, and it kind of walked down. So the bug it actually found basically just came down to kind of a code smell that you might be pick up with manual review, of course, which is just this I column value, basically had a sentinel value or a special value that when it's used this, so this is part of an index constraint inside the database. So database, you can give it some constraints for the values that any particular column can hold, and it'll do those checks when you try to insert or update or delete or whatever. It'll perform these constraints to make sure they still exist. And you can give it the column for what column is this constraint applied to. And -1 was used like a special value for the row ID. Just by default, when you create a table, row ID is kind of like, it means the table has a row ID, which is like a 64-bit integer, your primary key. It's like your default setup. Most tables are going to have this row ID, but you can create tables without it. Basically just a special column that's, the auto incrementing integer number. And they found that there was in fact an edge case where, the fact that -1 could be passed in for what's usually a positive integer, like starting from 0 and going positive, found some code that basically didn't handle that, and ultimately results in array access at -2. How it got there, they started including what the LLM did, and I was kind of impressed reading through this, seeing its reasoning. We don't get all the information about what it did, all the code that it asked to read and stuff. They do include this, like the assistants. They include some of the information about its reasoning, how it led in there, how it came up with a test case or used a test case, and that test case didn't work at one point. So it's like, well, why doesn't this work? It doesn't have a build with whatever, so it like rewrites its own test case in order to test its theory about what might be a bug. And then when it crashes, it's like, okay, there is a bug, and it does like the root cause analysis. So I found this whole thing really interesting on how it basically generated a test case to hit this bug just by going with, in what feels like a relatively human way, where maybe it's not handling this case correctly, therefore create a test to try it, and it hits this assertion failure. Really cool, really interesting, and also the fact they tried to fuzz this same bug afterwards. And just as a note for doing manual review, that sort of sentinel value should always kind of be a trigger to at least look at all the callers of a function or all the users of that, because whenever you have those sorts of edge cases, where everybody needs to be aware of it, it's just the code smell, I guess. It's just one of those things that you can use to find bugs. It's not always going to have a bug there, but it is one of those things that frequently has issues, because you're kind of using a value for two things. You're using it as a column index, except in this one case. Like you have this other use for the same value.
Yeah, it's not like very intuitive. Even if it's documented, it's easy to skip over that in documentation. And then the other like fun thing that we see a ton in the podcast is, the fact that it is asserted that it's supposed to be above 0, but those asserts are obviously not compiled into release builds. Very common problem where it's checked, but it's not checked, actually.
It does seem like asserts in this case are maybe overused for the sake of being able to test code and like getting kind of that sort of information. So I don't think it's a fault of like, oh, they thought this, because I do remember us dealing with one assertion issue, I think in a C++ code base, where it felt like it was written as though they assumed that assertion would be run and like checked.
Oh yeah, no,
Um,
that's not what I'm saying. I'm just saying like the assert thing is a common thing that
it
you
is.
see.
Yeah, no, it definitely is. And it also kind of gives you a hint on what you might want to look for as a researcher, especially when asserts aren't compiled into the final product. Sometimes they are. Some projects do keep asserts, or they'll have an assert that is and some that aren't. But yeah, that sort of code smell is definitely something to be aware of, to look for. And the last interesting thing here was that even knowing this bug, fuzzing still had a hard time trying to reach it. They were able to get to it with fuzzing, but ultimately, first they just tried to have it like fuzz and look at why. Why didn't the fuzzers catch it at all? That was easily explained as this just wasn't fuzzing yet. Like the OSS fuzz project didn't have the generate series extension enabled, so it just wouldn't hit this. And then the fuzzshell.c harness, which was part of oh no, that wasn't the one that was part of the AFL repo, but that was another harness. It had an older version of this vulnerable function that wasn't vulnerable. Therefore, it couldn't reach it. So, like, basically, those two just couldn't reach it, and SQLite AFL repository did have the ability to reach it, but appears not to be widely used. But then they did try and fuzz it by giving a fuzzing corpus that, knew or had the vulnerable function, knew about the keyword, and let AFL run. And with 150 CPU hours, which I mean isn't that long of fuzzing, but they're giving it the knowledge that it needs directly, it wasn't able to find it, and that's just kind of exemplifying why coverage base isn't necessarily going to find all your bugs. It could cover the code. They have like that 100% test coverage. All the lines are covered, not necessarily in the way that brings out the vulnerability here. They did manage to get this. They mentioned here it seems this bug was only quickly found if the corpus contained an example very close to the crashing input. And then they say, as code coverage doesn't appear to be a reliable guide for this particular issue. So it is interesting. This is LLM being used on a heavily fuzzed project to find a bug that fuzzing wasn't super capable of finding. Fuzzing definitely could have hit this. Like, I imagine more time. It eventually would have been hit, but it wasn't found quickly with fuzzing. And they also call out, and we should too, AFL isn't necessarily the best choice for trying to fuzz something like a SQL engine. Um,
It's really good for like images or things that are like have a lot of binary specific stuff to them where you have a lot of different input, like the input space is very large. But when you're talking about text where like you have to have valid text tokens in order to get deeper into the code and stuff, like it's not as optimal.
yeah, and you can do some things when it comes to like the harness, translating things into proper text and trying to deal with some of that, which I assume they're doing to some degree also, but there's just other options when it comes to fuzzing. And that is also why I'm a fan of having people learn all of fuzzing rather than just go learn AFL or AFL plus plus or something. Because
Yeah.
you end up treating those tools like a hammer and you figure out how to fuzz everything with them instead of figuring out what's a bit more useful for it. Nonetheless, like AFL has found plenty of bugs, so you can do it. It has been used, and all is good, and it's all good there. But it is worth noting that it's not the ideal fuzzer, but you've got the fuzzing meme that I like to reference.
Yeah.
Sometimes doing the dumb thing just works.
Yeah. So like you said, I think it was interesting seeing some of the reasoning and how the LLM was trying to approach things. One thing that wasn't really clear to me, maybe I just missed it in the post and maybe you can correct me, Z. It didn't seem obvious how they were actually prompting this because I'm kind of curious how much of it was like automatically prompting, sort of going from a commit and then sort of generating prompts that continues this chain of the assistant messages, or if they had a human in the loop um prompting based on the assistant's responses. I would kind of assume the latter. That's kind of the more typical workflow. But if they were able to automate the prompts in a way
The
to
prompt should have been
have
automated. That's the whole point of it being automated. like vulnerability
Well,
researcher, and that's where
I
like the
mean,
tree of thought comes in that I was talking about, the prompting frameworks, where
yes,
it's
like it's there's ambiguity there. They don't say one way or the other. It doesn't have to be fully automated. You can have a researcher kind of helping it along and pushing it past where it
I
might get blocked.
don't think that's what's going on here though, because they talk about this in the context of like the AI cyber challenge, which is fully automated.
Okay, fair
And
enough.
they
Yeah,
talk
yeah.
about this as like cyber sec eval, which again is for automating its ability to do this itself. Like I haven't looked at all the details actually on cyber sec eval, but I believe it's all automated. Like I don't think, like if
So
this
I
is
guess the
researcher in the loop, then I am far less impressed with anything because a researcher can tell it just, yeah, dig in, look at this code, but they talk about
right.
it deciding to look at or wanting to know
So
about this code and stuff.
I guess the only manual part was like filtering the commits basically.
That's
Because
what it
that they
sounds
did
like.
manual.
There
Okay.
might be like some changes to the initial prompting, but I believe it like
Yeah, because they
they
say we then
don't.
adjusted the prompt to provide the agent with both a commit message and a different change and ask the agent. Okay. I was just I wasn't totally clear where the manual input was and where it wasn't, I guess, based on like their like the whole trajectory highlights section. But yeah, fair enough. If it is more automated, then that's the reason why. So
Yeah, so the Project Naptime post does kind of reference here. I didn't dig into all their reference links, but I'm going to pull up a couple papers they reference. But they have space for reasoning, and it's crucial that the LLMs are allowed to engage in extensive reasoning process. And that is where I guess they're not doing. I had mentioned. Oh, actually, they are. They reference that chain of thought prompting, which is what I was just speculating about. Where using that as part of their prompting there, yeah, chain of thought and show your work. Scratch pads for intermediate computation. I'll add both of these papers into our reference there, but that's going to be more about how it's doing that continual prompting and like letting it reason and start asking for things to explore and stuff. And
mhm.
that's an area of AI that I've not really done much with, but I keep seeing it being used to great effect, and seems like I think ChatGPT or OpenAI's O1 model is kind of based around doing that sort of thing, but providing it automatically rather than you needing to build on or do anything with it.
Mhm.
But yeah, I would be far less impressed if this is just the researcher kind of telling you what all to look for. No, I believe this is the LLM doing it on its own and figuring out what to look at, which is what makes it really cool to me, seeing the reasoning that it has for the
Yeah.
assistant doing these things.
Yeah, I mean, again, like it is fairly impressive with the like how it was able to do the reasoning and stuff. But yeah, I just wasn't sure where exactly manual intervention could have happened. Um, so yeah, pretty cool post from Project Zero. Um, it is kind of leaning into trying to look at LLMs to sort of solve some of the gaps that exist in automated analysis, and that's totally fair. And while it may not go into all the technicals of how their model works and how all the prompting is engineered, it's still interesting to see kind of how that is done. And I wouldn't be surprised if some of that technical information is out there and can be found, and it's just not, you know, covered fully in the blog post because it's already long enough as it is.
Yeah, they reference the papers where they're like implementing what these papers are talking about for like the reasoning
Yeah.
processes coming from those papers, the interactive environment. So that's going to be the agents they provide, the specialized tools. Like they have kind of the research backing it up. So like the information is there if you want to follow up on this yourself, but it's not like they're giving you the tool to do it. And that's kind of
And
true
I
of a
am
lot of
interested if they
research.
will. Well, I am interested in Project Zero if specifically they will at some point because they are fairly open most of the time with like stuff they work on.
That's
So it could be like this is something in progress, and they finish off their blog post by saying, we'll look forward to providing more progress updates and stuff as we work on this. So it'll be interesting to see if there is like a more productized or user friendly tool that is eventually released based on this research. So it's
now
worth keeping an eye out for.
Yeah, for now, I kind of see in that same realm of like that. Well, QueryX are just talking about, it
Yeah.
shares a lot of information on how you can follow in their steps, but the specifics are left basically to the reader. And that's true with a lot of research projects, like a lot of research papers do the same thing. Like the research paper is pretty detailed, but if you try and like run their code, it is not going to be a fun time. Like you kind of have to follow their steps rather than uh try to get just the easy to use tool out of it.
All right, so I think we can move into some of the conference discussion. So Hexacon, it's a conference that both Z and I have been interested in since its inception. Unfortunately, we haven't been able to go. It's in Paris, which is a little bit far for us, and just not super easy to get to. But they do publish the talks relatively quickly after the conference. This is like 2 or 3 weeks later, if even that. So it's awesome how quick they've been in publishing the talks. One in particular that I got around to listening to before we did the podcast, and we want to have a bit of discussion around, was by Clem from Google's threat analysis group, and it's called Caught in the Wild: Past, Present, and Future. So this, of course, is talking about discovery of in the wild exploit chains and some of the methodology on how they discover exploits that are being used in the wild, and some of the tricks and stuff that exploits themselves will try to use to evade detection and evaluation and stuff. So there's a lot of really cool information in here. Obviously in the podcast before, we have covered posts from Google's tag and the in the wild reports. So yeah, we figured we'd pull this kind of into its own topic and have a bit of discussion on that and some of the points that we found interesting. One that you had found particularly interesting, Z, was talking a little bit about the private research that's done by attackers
Yeah, but
and
before you
the
go
public
there,
research, right?
before you go there, I do want to mention one other thing. So I know we're going to have a discussion about the public-private thing, so I want to get this more stupid thing out of the way first.
Yep.
One of the things I did find interesting is just that they mentioned like their first, because he talks about the first bug that they found in the wild and like doing that. I thought it was interesting. That was only in 2019. And so Google's tag, I believe, was only established in 2018. So perhaps that is purely limited to just Google's tag finding an in the wild bug, but I'm kind of surprised that it's that late for any in the wild bug from Google. So perhaps that is purely tag and not including anything that happened before. The way it was phrased though, like it just surprised me that was kind of that late that they didn't have anything before that operating on like those crash reports or something where they'd have had in the wild stuff kind of caught and realized. But yeah, I don't know. That kind of surprised me. There's not a lot we can say about it, but it did stand out.
Yeah. And he kind of mentioned that part of the reason he wanted to give this talk is because there was a lot of like misinformation out there about how like Google collects the 0 days that are being exploited. Did they have some comments there posting like, oh, they have backdoors and everything, and they're using Google Analytics, and just some of your common fear mongering kind of messages, and kind of wanting to put that to bed.
Listen, I store all my O days in my Google Drive. I mean, that is where it belongs. I don't use
Best place for them.
repositories. It's Google Drive.
Yeah, and Microsoft is stealing all the rest of your exploits from GitHub. So
Well, no, they're forcing them onto OneDrive.
or yeah, that's it.
Although GitHub's a good one too.
But yeah, so I would recommend anyone who hasn't watched this talk already, definitely check it out. There's a lot of interesting information there. He talks about so what I found interesting before we get into the public research session, I guess, they talk a little bit of how they fingerprint certain code techniques. So I didn't quite realize that they were doing this, but it totally makes sense. So some things that they look at, for example, is with browsers. Browsers are kind of their main like vehicle for talking about this stuff, because when you're talking about in the wild exploits, you need that initial entry point, and browsers are the most common one. They'll look for certain things that the code is doing that would pretty much only be done by exploits that no legitimate JavaScript code will be doing. So things like triggering the garbage collector, where you'll have a loop that'll run like hundreds of thousands of times or whatever, allocating large arrays. That's not something that any typical legitimate code is going to be doing, but it is something that exploit code will be doing to try to, get into a stable state or trigger the garbage collector to get some bug to work. So they kind of try to look for certain things like that and try to use that to detect like if there's malicious code that would be running. So I thought that was kind of interesting. It sort of has like anti-cheat sort of vibes where they're looking for those kinds of signatures, which is pretty cool and kind of hard to actually get around in exploit code because a lot of that is going to be boilerplate, right? It's going to be something you're going to have to do often. It's not something you want to have to rewrite, or if you try to get around some of the evasion tech or the detection techniques, you might end up messing with the stability of your exploit, especially in the browser where like one line of code has significant implications on the engine state. So yeah, I mean, there's a lot of interesting information on that. It kind of touches on the modular design of exploits as well, with reusing certain techniques and bypasses and how that can be leveraged for detection. That is kind of how they're able to get a foothold on the detection side as well. Whereas if everything was like unique and tailored to each individual exploit, it'd be a lot harder to do some of that detection. So yeah, I mean, just a lot of insights into that cat and mouse game, I guess.
Yeah,
Um,
it was a really interesting post on that front, and should mention they do talk about like a lot of code does get obfuscated, especially in terms of what's actually happening versus just researcher content. Like public research ends up being more obfuscated and harder to necessarily detect, but the code patterns can still kind of exist, just maybe not directly. Like I've got the slide up on screen, I believe, where they're talking about some of the patterns there. But yeah, one of the things that came up during the whole presentation that he mentioned that didn't really take me by surprise because it's something I already kind of understood, that's not magic, but I think might take some of our listeners a little bit by surprise, but would definitely take, I think, a lot of newcomers by surprise, is that there wasn't that much of a gap between public research and what the private research looks like what's kind of exploits that are being developed in the wild being used on like actual attacks, real O days, and what's publicly available um are roughly on par. Do go into some of the differences. Like one of the very clear differences mentioned towards the end is like the implant development, how complex and sophisticated implants are. So the malware that's being delivered by an exploit, that is miles apart. Like there's huge
the
development
post
there.
exploitation, yeah.
Yeah, like there are differences, but oh no, I feel like I see this all the time on like Reddit and stuff where somebody's like, "Oh, I want to learn, the exploit development. Like, what darknet forums do I need to go on to learn this? Because like, the white hats just aren't at their level or something." And in reality, I think a lot of breakthroughs honestly happen more likely in academia where they're just like looking at mitigations and stuff well before they actually land anywhere. People are talking about CFI stuff well before we've actually seen a lot of code with CFI. Just academics, just here's a new thing to break, so let's break it. Like maybe that mitigation never hits, like never lands in real world code, and maybe it does, but like I think a lot of public research is people are interested in breaking new stuff even before it's necessarily relevant, which ends up meaning that public research not necessarily gets ahead of private, but ends up like existing in this space where there isn't that much more that the private side can really be doing besides the fact that they're going to invest more time in like finding bugs, but like it's not magic. There's nothing really hidden that's like, oh, we have no idea about this sort of thing. Like it's not magic. There is this clear path between things that the private researchers generally is going to be pretty similar, and that's kind of what they found here. The main place where there was a difference was the Sandbox escape. So there was like public Chrome O days versus private tend to look about the same, although of course private ones tend to use more like obfuscation on their delivery and such. But the Sandbox escapes, because that's kind of this middle area that's maybe less interesting to researchers, because you're already somewhat privileged, already compromised. It just kind of sits in this middle place, and maybe there isn't a lot of public research focus there because I think researchers aren't necessarily going to want to spend the time on that versus promo day or like privilege escalation bug. Like that middle ground just isn't quite as
Doesn't have as
interesting.
much overlap. Yeah.
Yeah. So that's one place where there were more exploits and maybe doing something a little different. But when it came to places that like there's public research, they even actually talk about how like some of these sandbox escapes, like GitHub Security Lab posts about a V8 sandbox escape, and then in private they start using the technique that's mentioned there. So
Yeah,
in that
and
case, like public led to the private using it, not the other way around.
yeah, and I was gonna say, like you mentioned that there isn't a lot of room to go beyond like what is sort of in the public eye, but even if there is, it's just not very practical for attackers to like come up with a bunch of novel research if they don't have to. A lot of it, like a lot of exploit development and such, like everything else, comes down to like cost benefit analysis, where it's like, do I want to spend a bunch of time coming up with a new technique where like once it's potentially burned, like all that novelty is lost. Like it just doesn't really make sense to do that if you don't have to. So yeah, it makes sense that a lot of like publicly documented techniques and stuff get leveraged. Something that I thought was kind of interesting that I hadn't really thought about before was reuse of 0 days. So you kind of have like your two states that everyone's familiar with. You have like an O day or it's an N day. If it gets patched and it can be used on older versions, there's the N day portion of it. But something he kind of talked about was the reuse of ODAs after they're burned via launching other applications that can have the out of date version. So, like, even if the primary browser, for example, is updated and patched against a vulnerability that an adversary would be leveraging, they would use some other pathway or like intents or something to try to launch a different application that had a browser with an outdated version. And, in hindsight, like that totally makes sense that they would want to get as much as they can out of a particular exploit chain or whatever. But it's kind of interesting in how they can leverage like the bundling of older browsers in that way in an automated fashion.
Yeah,
Obviously I
there
think about that in terms of manual like self attacks, like for console stuff, that's very common. But in an automated way for adversaries to use, I hadn't really thought about them using it in that way.
Yeah, I think the specific case that he kind of mentions is like, a Chrome bug, maybe that's patched, so it's going to detect that and then try and raise an intent to get like this Samsung built in, like the WebView browser, which is going to be using an older version, Chromium thing, and kind of getting it in there, getting some applications probably I think will provide their own WebView uh options also, like, so yeah, they're able to get the older exploit that way basically. Yeah, though I hadn't really thought too much of that side either. Totally makes sense that they're doing that and like using, because that is kind of just the whole patch gap, just a little bit more extreme because it's not just the patch gap, it's like everybody's patch gap, but kind of the same deal.
Yeah.
And so we've spent a lot of time talking about like the browser RCs. It does also get into like Android patch gapping and what they're seeing on like iOS and like the trends on the privilege escalations too. A lot of things kind of have overlaps. I don't think there's much discussion we can really have between them, but I did find it just an interesting post in general, just seeing the stuff in the wild because we don't get a lot of insight unless it's like some really well known thing. Um,
Yeah, you typically see like one, maybe two headliner in the wild chains a year, and I think that's kind of like decreasing over time because I think he kind of touches on this in the talk too. But like, as the bar is raised for like these full chains, you're not really going to see full chains the same way you did like 5 years ago. There's going to be kind of this shift in the meta towards like partial chains where you're kind of plugging different things together that work, but you don't have like full chains of O days going directly from remote context to root on a system. Like it's just there's so many layers of security being added now that that's just not very cost efficient. So you're kind of seeing a move towards the more partial chains, and again, that kind of limits your visibility a little bit too.
Yeah, and that's
Um,
something that we've actually talked about in like the future of exploit dev. One of the
yeah,
things I tend to mention is, where I see exploit dev and vuln research going is, he puts it pretty succinctly here, is all bugs will matter. It's not just that memory corruption, but it's these other sort of issues that'll come up too, that'll let you get information, that'll let you do little things, but maybe not code execution, but you'll still use it. And yeah, he calls out an example there where they had one thing I think must have been on iOS because it was Safari. Uh, Basically just compromised Safari, dumped all the cookies, and that was it. Like it didn't go further. It just did that quick task, like stole cookies, and that's super impactful still. Like you can do a lot with that, and it's just like the partial chain. It's not this full chain. It's here's a partial, and they're already kind of seeing that. Uh, so yeah, I thought that
yeah,
was another interesting and just kind of a sell on what I've been saying too, where these other bugs and vulnerability research that isn't just resulting in code execution is going to matter more as code execution gets harder and harder to gain.
yeah. And actually, as like a bit of a feedback loop between this talk and another one, the Hexacon opening keynote talks a little bit about the meta of that too. Talking about like the sort of cost of chains, and it gets a little bit into the ethics as well. It's a little bit rambly, which the conference organizer acknowledges when they're talking about it. But he actually references this talk and kind of was hoping, because like in real life it happened before this talk was given. Renaud Fowl is the person. I probably said that wrong. I apologize. But he was kind of saying what he was hoping Clem would talk about, and sort of talked a little bit about that the partial chain versus full chain thing, and the idea that perhaps in the future there will be more of a shift towards using like backdoors because the cost will just get too high for these exploit chains. And I don't think that's going to happen immediately or anything, but sort of talks about the future of exploitation in that way. So yeah, that's another talk that I had checked out. I haven't gotten to check out a ton of the other like talks that were given at Hexacon. It is fairly new. They were only put out a couple days ago. Z, I believe you've gotten through a few others, so I don't know if there's any that you wanted to talk about.
Yeah, I got through a few. I will say I usually ignore like the opening, like it's not you're not
Me
knowing
too,
anything
but
about
it
it.
kind of auto played into it, and I was like, oh, this is kind of interesting, so I continue listening to it.
Yeah, fair enough. I didn't even think about clicking on it. I just didn't really like no hate to people or anything doing it. I assume it's going to be well more like COD related, not like an
More
actual
just like,
talk.
yeah, introducing people to the conference. Yeah, that
Yeah.
is the main purpose of it. Yeah.
So yeah, maybe I'll have to check that out. What I did check out obviously was this COD in the Wild post. I did also take a look at this hardware security module, HSM or one here. I'm trying to see if I can find it with just the search.
HSM security and
Yeah, here we go.
exploitation. Yeah.
Security and exploitation of USB over a spy bug. It was dealing with like a hardware implementation of like a Ledger Nano hardware wallet. Physical device for based on that did have some changes. Bug itself not super interesting. Well, kind of, I guess. It was just a little bit weird. So basically, microcontroller, they were reverse engineering the firmware and saw this micro or saw that as it's reading the data off the spy, like it has this USB function, and like why is it dealing with USB? Turns out the microcontroller was basically just proxying all of the USB packets straight to the firmware over the spy data, uh, over that pin. Was basically just proxying it all over there, and then in the firmware in the security module, um, it was parsing USB packets, and naturally there was a vulnerability there. Kind of a simple one where it had a fixed 128 size buffer. You could send more as part of the USB packet, and it would go ahead and just overflow in the what's memory? The microcontroller's memory. Sorry, not sure why that word
SRAM.
I slipped. No, it was just they just referred to it as the microcontroller's memory during the post.
Oh, okay.
Like it wasn't any special term there. I just completely forgot microcontroller. That's the only word I completely slipped on there.
Ah,
Either
okay.
way, like the bug itself is not super interesting. Nonetheless, I checked it out. if you have an interest in that area, perhaps I think it is kind of emblematic of just a lot of embedded and like low level style vulns that we see, where it's just these really stupid vulnerabilities that kind of stay hidden because they're hard to actually reach. So I checked out that. I checked out the AMD sync close universal ring -2. Where is that here?
You can probably control F SMM because that's ultimately what they're getting. Yeah, it's from the IOActive guys. I think I
Okay.
mentioned that talk was at Hardware as well. I didn't manage to catch it, but I have gone through the slides, and their research is very cool.
Yeah, and again, the bug itself's pretty easy, or at least would be pretty easy to understand. Assuming you understand like SMRAM, kind of what that kind of exists, and like MMIO, basically just by flipping a bit, which was in this tseg mask, flipping a bit, and suddenly it's going to trust or do all of its data fetches through the MMIO, which existed for like old compatibility reasons, but nobody actually uses it. But goes to the MMIO, which means the attacker can now control all the data that it's fetching, and so they were able to exploit that. Kind of a cool bug, very fundamental. Like it's not exactly by design, but like the very fundamental bug. And they go into way more details, obviously, than I'm going to go through here. But it was a good presentation. I did find that interesting.
Yeah.
And those were the two talks that I had a chance to take a look at now. I did take a look actually, I guess, at or I got through part of VMware guest. Yeah, compromising the host kernel from VMware guest. But I didn't finish going through that one yet, so no final commentary on it. Yeah, there's a few more I want to check out, but I do think the AMD ones maybe worth a quick listen if you're interested, but definitely check out this Caught in the Wild one. I think pretty much for anybody, there's some interesting information there. Even if you're not doing a lot of binary level work or something, it's more on the threat side, so it's a bit more high level and interesting on that front.
Yeah. Another conference that's even fresher was Usenix's WOOT conference. So this was just put out a day ago, so I have not really gone through any of the talks. These are a little bit more, I guess, academic in nature, from Usenix, obviously. So yeah, did want to give it a shout out. There are a few talk titles that do look interesting to me, like breaking RSA auth and bitstream recovery on a FPGA. There's a few talks like that are pretty interesting that I'm going to check out. But yeah, I haven't really gotten a chance to watch through any of them yet, so I don't want to really talk about them too much during the podcast. But I
Yeah,
do want to shout them out. Take a look, see if there's some talks that are interesting to you.
the nice thing about the Woo talks and just generally uh the more academic talks is they do tend to be shorter so you can get through them fairly quickly. So with that, being able to get through them, like a lot of them are like 15 to 20 minutes, despite being very, or perhaps not very technical, but like dealing with some more technical issues. They are more academic things, and there's a paper to go along with them. So you get more information there. I did check out a few of them that I'll give a quick rundown on because they're the ones that I did look at. First one I went for was on the effectiveness of CFI, of control flow integrity in practice. Honestly, if you've listened to us talk about CFI before, like bypassing it and stuff and dealing with it, I don't think there's really much new that was presented here. They talk about the fact that, yeah, like, CFI, coarse grained, you've got other gadgets going on. Kind of talk about where academia is with a lot more fine grained or like tighter grained stuff. And just like the practical fact that not all code has CFI, therefore there's all these other gadgets available. I didn't see anything too new on that one, but I did give it a watch, so figured I'd at least mention it. Similarly, exploiting Android's hardened memory allocator. There was some good background on like how Scudo works. Android's hardened memory allocator is called Scudo. Had some decent background. We did talk about a Synactive post a while back that also had background on Scudo that maybe was a little bit better. I almost felt like this was a bit of a bait and switch, to be honest, because in fairness, like reading the title after the fact, maybe I just had poor expectations, but it ended up abusing just the fact that Zygote exists. And with Zygote, if you're familiar with it on Android, whenever you do like app to app sort of attacks, like you kind of get an ASLR break for free because most apps will end up just forking the Zygote process. And then they're going to have all the same starting, like the same randomization information, and that includes the same pseudo security keys and like that information. So like you could just break it that way with like a, if you already have a malicious app and you're going for like a system service or something like that. Like there is an attack scenario for that, but that was kind of the break. I don't know. I mean, it just felt a little bit weak to me, but maybe that's just me. Like I was expecting something more focused on like pseudo standalone, like something else ran it too, not the Android issue. Because Zygote's kind of a break for a lot of things, unfortunately. I did also go through the not quite right on the effectiveness of store only bounce checking. Wasn't even really familiar with this as a mitigation sort of deal. It's like a performance optimization and mitigation, like do bounce checking in a variety of ways. Uh but only when you do the right, and basically just showing how that is fundamentally broken using an example of, an out of bounds array access where it's going to read a pointer. And so it could read the wrong pointer, gets the read because that's free, that's not protected. And then it's just going to check bounds on whatever pointer you're actually accessing and not necessarily whether or not it's what you expect. Basically, just showing a pretty fundamental break of the idea because you need to protect the reads, um even if you think that because it kind of, the theory makes sense. Like I kind of get the idea where a lot of corruptions need you to be able to write, so if you protect all your rights you're okay, and just shows like a fundamental code pattern everybody does that completely breaks it. That said, I don't think store only bounce checking is a mitigation that I've ever seen like on anything. They do call some implementations of it out, like do mention this, but this is one of those cases of academia kind of being ahead, and I don't think we're ever going to see this happen. But I did enjoy the presentation still. Like it was still kind of interesting, thinking about it, see it, and yeah, pretty fundamental break kind of on it. Overall, like I went through a few of the talks, some of them maybe not the most worthwhile use of my time, but like none of them were bad presentations. I will say that. Like they covered what they're supposed to. I didn't necessarily care for the end result. Like I mentioned with the Android one, it's kind of the same deal with a lot of papers, to be fair. And these are ultimately just videos of papers. So yeah, there were a few talks I checked out, but the WOOT talks are up and available, and I do find the talks to be a lot more digestible than the papers. So
yeah, the papers can be really tough to get through. So when there are talks that touch on like give a summary sort of what the paper's about, that's a lot easier to digest. So
yeah, the papers usually are a lot more detailed. Like the talks are usually, because they're only like 15 to 20 minutes, they do need to cut out information. And so the talks usually do just make it more digestible by not covering everything. Yeah, I guess this, me talking about WOOT kind of came out a bit more negative than I maybe intended it to be. Even with the control flow integrity thing not necessarily having anything new, like it's still just being documented here and actually taking a look at it, like things that we've had the feeling of for a while. Like it's documenting, it's kind of proving it there, like it is doing novel research, so no hate on the researcher for doing it. It's not like it shouldn't be done. Same deal with the Zygote thing, like it exists, it's something to document and should be noted. So I was kind of coming across maybe a bit negative because I kind of want more exciting vulnerabilities, but research isn't always going to be exciting, but it still can be valuable.
all right, so we do also have a few other shout outs, quick shout outs we'll get through, and then we'll wrap up the show.
Yeah, a couple shout outs. One was this post from GitHub Security, which is securing the open source supply chain, the essential role of CVEs. And it's really just talking about CVEs, CNAs, and actually, I guess there was a rule change to CVEs that happened in May. I didn't know about this, but apparently the new rule is that should assign. So we've talked about CVEs and things that don't get CVEs being like, um, random web app doesn't get a CVE because nobody's really updating that except the one, like nobody, there's no action anybody needs to take besides that vendor. Turns out now the new rule for CVE is that basically if a vulnerability could have caused like significant damage, it should get a CV. Even so, this is in the case of like cloud. The main example is with cloud issues. Um, they comment here how disclosing vulnerabilities in cloud-related products has been a point of contention. Prevailing reason against it is just to avoid generating alerts that don't require user action to remediate. And yeah, CVE rules were updated. I had no idea about that, so I found that interesting. Kind of went down a quick rabbit hole about the changes there that would also lead to having more CVs kind of come out. So yeah, there's that. I don't know. I just found the whole thing kind of as an interesting read. There's nothing super like VR or exploit related. It's just some CVE stuff. And the second post that I had as a quick shout out was this new era of macOS Sandbox escapes, diving into an overlooked attack surface, uncovering 10 plus new vulnerabilities. And that's the blog post kind of accompanies a presentation at Power of Community 2024, which of course we won't get videos for because POC doesn't do that. I kind of had this more as a shout just on the idea of finding those overlooked attack surfaces. We touched on this during the Naptime discussion earlier, Project Naptime, where one of the hard parts about vulnerability research is finding the right place to look in the first place. And so this is just a case of here's an attack service that seemed to be overlooked, and it turns out like these services, we can reach them, we can do something with this, they have privileges, and like they're not doing appropriate checks. Like it's just this kind of overlooked domain, I guess. I don't understand all the details on this one, and I will be honest, I did not go through every vulnerability they found on this, but it does look like a lot of information if you're interested on the Mac side. And I had wanted to shout it out initially as one of our topics, just on the idea of overlooked attack surface, because finding attack surfaces is one of the hard parts of VR. It's not necessarily reading the code, well, I guess it can kind of be reading the code too to find attack surfaces, but attack surfaces are kind of key and maybe not talked about enough.
All right, so that concludes the shoutouts that we had for today. So as always, thanks goes out to everyone who tuned in, and we will catch you next week.